right, this is the part 2 video, and we're really going to go through the examples here. So first we're going to say whether it opens up or opens down. I'm actually going to go through these one at a time. Opens up or opens down. Well, opens up or opens down really depends on the leading coefficient and whether it is negative or not. If it is negative, it's going to open down. If the leading coefficient is positive, it's going to open up. So this one is down. Down, up, down. So this actually, that up or down actually should go fairly quick. This one's down, the leading coefficient. The x squared coefficient is down, is a negative. So this one, sorry, almost gotcha. It's going to go up because the leading coefficient is positive. This one is going to go up. Technically, this leading coefficient is positive. So that's how we know up or down. Now, axis of symmetry. This changes a little bit if you remember. This B, depending on what we're given. So if we're given standard, it's negative B over 2A. Now sometimes there is no, we have to think of it as like 0x in there. So really what happens here when we go our negative B, it's like a negative 0 over 2 times a negative 3. Well, 0 divided by anything is still 0. So our axis of symmetry in this case is at x equals 0. So when there is no b value, it's going to be a 0. In this case, if you remember, this is like a plus 0 here. And so this is the vertex form. So in this one, the vertex, and I'm going to see here, that actually goes in C here. The vertex is easy to see. It's going to be at 3, 0. All right, so this is in vertex form. And what is the axis of symmetry would then just be x equals 3. It's your p-value there. All right. Again, we have number 5 is in vertex form. All right. So again, when I see it in vertex form, I'm going to just quickly write down what the vertex is. And then the axis of symmetry always has to match my x value of the vertex form. In standard form, takes a little bit more time, takes a little bit more effort. It's going to be that negative b, so the negative of a negative 3 over 2 times a over 2 times negative 2. Negative b would be a positive 3, and then this would be a negative 4. So my answer here is x equals negative 3/4. Kind of a screwy axis of symmetry, but that's all we need to have there. In this case, we have to think of it as like a plus 0 there. Again, we're going to go, it's the same negative b over 2a, so the negative of a negative 2 over 2 times 3. So we have 2 over 6, which would be x equals 1/3. That's our axis of symmetry there. Here, if you remind yourself, we have intercepts. And the axis of symmetry are the two intercepts halfway between them, divided by 2. So in this case, it's going to be 6 divided by 2. And so my axis of symmetry is going to be at x equals 3. Sorry about that. There we go. All right, x equals 3. All right, so now let's go and we'll go back up here and we'll say, okay, what's our next thing? Oh, the vertexes, the vertices. So now we're going to be working on our vertices. All right, in this first equation, when we have our x value, and I know I'm running out of space here, your vertice is going to be that always the same. So these two will always match. So I just need to find out what would y be when x is 0? Well, if this was a big old 0 here, my y is going to be a 1. So I'm just going to, I kind of have that there. Here I already have my vertices because those are in vertex form. Down here in number 2, my vertice would be a negative 3/4. And then I'm going to have to calculate. So sometimes you have to calculate. I'm going to pause it and calculate it. This one actually turns out to be negative 3/4 and 51 over 8. Icky! I promise we won't throw one like that on a test. That's just too involved. This one hopefully is a little bit easier. Here we'd have negative 1/3, and then 1/3 squared is 1/9, so 3 times 1/9, minus 2 times 1/3. Still kind of icky. So you have 3/9, which is 1/3, minus 2/3, so it turns out to be a negative 1/3. All right, here when we put in a 3, we'd have 3 minus 4 here, which would be negative 1, and 3 minus 2, which would be positive 1, and we're multiplying them, so it's going to be a negative 1. Okay. The last thing, or one of the last things, we have a D and E. D is the max or minimum value, which is kind of odd because that's your vertex. That's weird. I didn't make up this review. I don't know if I really like them. Oh, is it a max? No, I don't know. Huh. I'm going to get rid of this. I don't like this question at all. Now we're going to look at, is there an X or Y intercepts? Really, the only one it applies to is if we have a Y-intercept. Well, here the vertex happens to be the Y-intercept, so we're fine. Here I could say my Y-intercept might be the only one I look at here. My y-intercept, if x is 0, would be negative 3, 9, 0, 27. So that's kind of interesting. Here, my y-intercept, if x is 0, would be 2 times 1 is 2 plus 3, 5. Oh, negative 2, so negative 1. Sorry, it's going to be 0, 1. So sometimes that y-intercept helps. Here, the y-intercept would help. So when it's 0, it's going to be 3. In standard form, the y-intercept is always going to be the constant. Here, it helps. It's going to be at 0, 0. That's going to be my y-intercept. This one's good in that we can find my x-intercepts. So I can say my x-intercepts, in other words, where y is 0 is going to be at 4. So 4, 0 is in there, and 2, 0. So it depends on which one you're going to use. Which one is more important, is the x-intercept or the y-intercept. All right, so I'm going to jump here and say, okay, determine if this ordered pair is a solution or not. It's not so bad, and I don't think I can split these up. Sorry, they're together. So I'm going to start by just solving 13 here. I just want to go through a couple of these. I don't think we have to go through all of them once you kind of see how these work out. So we'll give you these and say, okay, we have this inequality. And it's just kind of getting you used to, getting you ready for inequality. And when I plug in a 1 for x and a 6 for y, do I have a true statement or not? So I'm asking myself, is 6, it's kind of this question, is 6 less than 1 squared plus 2 times 1 plus 2? So you kind of ask yourself that question. 1 squared is 1, plus 2 is 3, plus 2 is 4. Is 6 less than 4? The answer is no. Once you get a no, it's a no. You don't even have to try the other number. Let's do another one. Let's do 15 here. Now we have the equation y is less than or equal to 2x squared minus 7x. And we're going to try x is 4, y is 4. So is 4, we're kind of, again, asking ourselves, less than or equal to 2 times 4 squared minus 7 times 4. 2 times 4 squared is 2 times 16. 2 times 16 is 32 minus 28, which is 4. Is 4 less than or equal to 4? The answer is yes, it is. So now what we have to do is we have to check the other number. So it's kind of for both sets. So now we're asking ourselves, when y is a negative 5 and x is a positive 1, do I have a true statement? So is negative 5 less than or equal to 2 minus 7? Is negative 5 less than or equal to negative 5? And again, we have a yes. 2 yeses make a yes. 1 no makes a no. Okay? So that's just how you do those examples. Now let's look at some. So we're looking at stating the equation for the axis of symmetry and the vertex. Just kind of going through, okay, we have to graph this. So when I look at this, I say, okay, we have standard form. So I'm going to be looking at negative b over 2a. So negative b would be a 0. There is no b there. Remember, it's like a plus a 0x. Does it matter what it's over? No, not at all. My axis of symmetry is at x equals 0. So when I'm looking at making my axis of symmetry here, it's right here at x equals 0. Now, I know that my vertex has to be somewhere along there, somewhere along that 0. So I just have to plug in a 0. So what is y when x is 0? It's at negative 3. 1, 2, 3. Here's my y when x is 0. Now the hard part is we used to say we're using the y-intercept to say how does it curve, but we don't have that y-intercept. So we have to pick another point. There are millions of points here along here. We don't know how it curves, but there's millions of points there. So we just have to pick one of them and say, how does it curve? So let's pick 2. All right, so let's pick what is y when x is 2. I could have picked 4, I could have picked 1, I could pick -7. It doesn't matter. So I'm just picking 1, so I'm like, okay, where is y going to be when x is 2? Here I have 4 minus 3, so y is at 1. So in other words, the point 2 comma 1 solves this or is on this curve. So at 2, 1, I'm on this curve. So this, I know it kind of curves up like this. So what I know is that here at -2, it's going to curve in the same, so that I have that symmetry. It's going to be the same on both sides of my dashed line here. All right, let's look at another one here. Now, I actually am given intercept form. It doesn't quite look like intercept form, but it is intercept form, because what I'm given is really this, x plus 0 and x minus 4. So I did have intercept form. So what I know right away, and what I like to do with these, is I like to right away draw in my intercepts. Here's my one intercept at 0. Here is my other intercept, 1, 2, 3, 4. Remember, it's what makes that grouping a 0. All right. I have to think about where is my axis of symmetry. My axis of symmetry is going to be halfway in between there. So that is not a very straight line, but we're going to do halfway in between there. So I like to just kind of calculate it by visual. Calculate here that it's 2. I could have also taken 0 plus 2 divided by 2, which we would have gotten 2 for an answer. 0 plus 4, sorry, divided by 2. Did it wrong. Because my two intercepts were 0 and 4. 0 plus 4 divided by 2, which is 2. So my vertex is at 2 comma something. So I have to go back to my original equation, and really I'm thinking of this as an equal sign right now. I'll deal with that greater than or equal to in a minute. What happens when x is indeed a 2? So here we have 2 plus 0 and 2 minus 4. I could put in there 0. So we really have 2 times the -2. So it's at -4. So the point in there is at -4. So we know that's my vertex. So here's 2, 1, 2, 3, 4. Here's my vertex. So I can graph it pretty quickly. I can see how it kind of graphs fairly quickly because I have my intercepts and I have my vertex. Let's do another one. Axis of symmetry. This one is going to be at the -b over 2a. -b would be -4 over 2 times -2. So it's going to be -4 over -4, which is 1. My axis of symmetry is at x equals 1. So my axis of symmetry is right here at x equals 1. So vertex has to be, where is the y when x is a 1? So I'm going to my original equation up here, y equals -2 times, when x is a 1, it'd be 1 squared plus 4 times 1. So it would be -2 plus 4 at 2. So we're at the point 1 comma 2. 1 comma 2 is right here. Now we have to see, how does it curve down? Easiest point is to ask, what is going to be y when x is a 0? And when x is a 0, y is also a 0. So we're here at the point 0, 0. So I know it curves down like this. If it goes 2 down and 1 over here, it has to go 2 down, 1 over here, because it has to curve down like that. So I can find my curve. Next one is in vertex form already. So I should be able to really quickly go, oh, vertex form here is at -1, 3. My axis of symmetry is at x equals -1. Let's draw in the axis of symmetry first here. So -1, sorry, is right, I gotta get that to move right there. -1, +3 is right here. Let's see how it curves. Let's see what is y. Oh, I have to go back and do something. Just remembered something. All right, so I've been into just graphing these parabolas. I'll go back and do the inequalities here in a minute. So here I'd have 1 squared, or 1 plus 3, and I have 4. So y, I'm going to really thinking of this as an equal sign here, is at 0, 1, 2, 3, 4. So it curves up like that. Symmetry. All right, now we have to deal with the fact that here we have a less than symbol, not an equal sign. Less than says, where on this line does y get lower or less? And the answer is, it's down here. So we should shade here. The other thing we need to do is this is actually should be a dashed line because it's not less than or equal to, it's just less than. Let's go back to the graph I've already done, and we have to do this one, greater than or equal to. I'm going to do this one in green. Now I can leave my solid line, but where is it greater? Greater is inside, not always inside, but for this one, I have to think where's my line, and it's where y gets higher as it gets greater, so it's going to be inside. All right, there wasn't an inequality there. So the shading, greater is going to be above, less than is going to be below. And it might be inside of a group of a parabola or outside depending on how it's drawn. Okay? I'm going to do a little bit more here. I have another axis. I have intercepts right here. I can look at this and say I have here at -2 and at +4. 1, 2, 3, 4. I can say my axis of symmetry is -2 plus 4 divided by 2, or at 1. I know at 1, I have to find my vertex. So at 1, it's 1 plus 2. I'm asking myself, what is y when x is 1? So it's 3 times -3, or -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, down here, and then you just graph it. I know I'm doing this kind of quick. Here, I know I'm going to have an upside down graph. When I look at it, I can see I have my axis of symmetry is at, or my vertex, sorry, is at 4, 8. My axis of symmetry is at 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. Axis of symmetry would be here. I'm going to see how does it curve down, but I'm seeing what happens when we have a 0 in for an x. -4 squared is 16. 16 plus 8 is 24. So wow, way up at 24. Actually, it should be negative. What did I do wrong? Oh, it's a negative out in front of this. So it's -16. It's not so bad. And a +8, so it'd be -8 here. So I'm at 1, 2, 0. 1, 2, 3, 4, 5, 6, 7, 8 here. So this curves down like this, curves down like that on the other side. Below, it's going to shade below it. All right, so below my curve happens to be on the inside. It's not always on the inside. There we go. So we went through a lot here, but this is kind of the basics of how we graph parabolas.